All right, so back to solids. Remember that with solids, we said that atoms vibrate in place or vibrate about a fixed position. And there's kind of two general solids that we can classify things as either crystalline or amorphous. Crystalline means that they have a definite repeating pattern. While amorphous, they don't. They lack any sort of ordered structure. And we're, of course, going to focus more on the crystalline solids. So they pack in some kind of structure and then just repeats itself. So it can look really complex when you're looking out, but you can reduce it down to a simple unit that repeats, kind of like a kaleidoscope. Of course, these crystalline solids can still have defects. And sometimes we add these defects on purpose. Because if we can control the atomic or the molecular structure of our compound, we can control its properties. So for example, with semiconductors, which are the basis of like transistors in modern day computers and all kinds of different things, touch screens, solar cells, all of these kinds of things. We can dope them, what it's called doping with like phosphorus or boron. You can take silicon, dope it with phosphorus and boron, and you can change the electrical properties of the material. Other examples include like gems. A lot of gems are actually kind of the same thing. For example, like rubies are aluminum oxide, which isn't really anything all that special, but this time it has with some chromium impurities. So that's why rubies are red, because of this small amount of chromium impurity. And then if you wanted it more red, you could add more chromium or less chromium, or you could add different metals and get different kinds of colors, that kind of thing. But generally, in a crystalline solid, right, we have some kind of ordered structure. And then we can have different types of defects. Let's just go ahead and identify the three main types of defects. Put a little star here, put a little star here. So we can see here, right, where there's supposed to be a circle, it's been replaced with this little star. This is what's known as a substitutional defect. Right, and in this case, a different atom subs out, right, where another atom should be. We can see in this little defect, we have this little purple star in a place that's normally not occupied. So this is called an interstitial defect. And this is just basically an impurity in a normally unoccupied space. And then over here, right, we have an empty spot that's called a vacancy. There should be some kind of material there, but it's not there. So oftentimes when you kind of grow crystals or grow crystalline compounds, you're going to naturally have some kind of defects in there. Sometimes you want these defects to change its properties. A lot of my PhD work was adding these defects into crystalline solids and then seeing how it affected their electronic and magnetic and optical properties.